Hi folks, welcome back to Math with Captain Rod. Making this video here to help you out with your homework in about graphing logarithmic functions. So this is an example here. This is number 44 in the college Algebra Openstax text in section 6.4 here. And what we're going to do is we're going to graph the function g of x equals log of 4x plus 16 plus 4. All right, so first of all, let's talk kind of general properties. Remember that the logarithmic function here, if you're going to take the log of something, this something has to be positive here. So the 4x plus 16 has to be greater than 0, strictly greater than, no equality. So 4x has to be greater than minus 16. So x has to be greater than minus 4. So this is the domain of this function. We're not going to have anything on the graph over here because this thing is only defined to the right of negative 4. Now remember, with logarithmic functions, when this is equal to 0 here, you get a vertical asymptote. So the equal 0 part will be at negative 4. I'm going to go ahead and put a green line there. 1, 2, 3, 4. So here's my vertical asymptote for this function. Vertical asymptotes are wonderful graphing aids. Okay, a vertical asymptote at x equals minus 4. All right, now this, the parent function, if you will, for this is y equals log x. And if you were to graph just a quick sketch of log x, that kind of looks like this. Goes through the point 1, 0. Right? And remember, in exponential form, this means 10 to the y equals x. You can see that y goes through the point 1, 0, because when y is 0, 10 to the 0 is 1. So this graph is going to look, something like this. The 4 is going to affect the horizontal type of behavior, and the 16 is going to shift it right or left. Now, you'll notice that if we write it if we factor the 4 out of this, we get 4 times x plus 4. I'm going to put plus 4 here. So you'll notice that this x plus 4 means that this graph is this thing shifted 4 units to the left. And again, the 4 is going to do a horizontal type of compression, and then this 4 is going to lift it up 4 units. So this graph is going to look, maybe kind of something like this. I'm going to go ahead and now just plot a couple points here real quick. This is how I plot points with logarithmic graphs. First of all, I'm going to rename that. Let's call this y equals log of, and I'll go back to this form here, 4x plus 16 plus 4. And what we want to do to get our points is to write this in exponential form. So what we can do is put this over on the left, right? Y minus 4 equals log of 4x plus 16. Now I'm going to write it in exponential form here. 10 to this power equals this thing. So 10 to the y minus 4 equals 4x plus 16. Now, we can reasonably easily get our points here. I'll do this over here. All right, x and y. Now usually, about 99% of the time, you're picking x's and finding y's. It's just easier here in these types of equations to pick y's and find x's. So some easy ones here. When y is equal to 4, that's an easy one. This equation is going to be 10 to the 0, which is 1, equals 4x plus 16. And we can solve this for x. Minus 15 equals 4x, so x is equal to minus 15 fourths. Now that's about, minus 16 fourths would be negative 4. So this is just to the right of that asymptote, and then it's a 4. So just to the right, and then 1, 2, 3, 4, maybe something like this. Let's see another easy point here. Let's say y were 8, or I'm sorry, 5. That should be a relatively easy one. All right, 5 minus 4 is 1. That equation is now going to read 10 equals 4x plus 16. Subtracting 16, this is going to be minus 6 equals 4x. Oops, was that a 16? Yeah, that's a 16. So x is minus 1.5. All right, so we know that this goes to the point negative 1.55. So negative 1.5, and then 1, 2, 3, 4, 5 is like here. Now, that's pretty well enough to sketch it, I think. We know that it approaches the asymptote. It's got to go straight down like this. I'm going to have this type of shape to it. Maybe a little bit. I guess I could have made that a little less of a curve right in that area, but that's it. That's the general shape of this graph. So basically, when you graph logarithmic functions, one, you want to know where their domain is. So this thing needs to be positive. You set up an inequality that states that. The equal 0 part will tell you where the vertical asymptote is. They have, this type of general shape to them. This one is shifted left and up, and that's why we're kind of up in this region here instead of like over here or over here. A couple 3 points is nice to plot them. In this case, I just plotted 2 points, but typically what you do is you pick values of y, or well, typically what you do is write it in exponential form, pick some y's, calculate x's. Probably should have picked one over here to the right somewhere, like y equals, say, what would have been another good one here? Boy, I think it's going to get off the graph in a hurry. Even y equals 6 is going to make this 100. So this one's a little tough because the thing's growing so fast to pick, nice values of y. On the next example, maybe I'll plot 2 or 3 points, or 3 or 4 points, I mean. So find your asymptote by setting this equal to 0. Plot just a couple of points here by writing it in exponential form like this. Pick a y, find an x, right? Put these points on a graph. That should be enough to sketch the rest of it. So I'm going to go ahead and call this video done and just make another example for you. Have a great day.